Welcome everybody to my presentation. My name is Michael. I'm an independent developer, and how can I turn that down? Right, and what you can see. Yeah, that's true, Sebastian. As you can see on the picture above, that's my normal office, my home office. I'm traveling right now. That's why my background is not as fancy and as nice. So just imagine the background above behind me, and then you can see me in my normal environment. But we are not here to talk about me or my environment. We are here to talk about how I reverse engineered a quadrocopter and replace the proprietary firmware with open source to turn this product well meant and also of not too bad quality into a package well done. And how did it all start? Well, that was way before 1996. And of course, I did not use a C64 to run PX4. But as with most of the brilliant ideas of nowadays, my idea or my project was inspired by a movie, actually. And the title of the movie is not that important. It was Gemini Man, and it's also not important that Will Smith was playing in it. But there was one scene that caught my eye. Here it is. Hope everybody can see it. So there's this guy throwing this package into the air. The package unfolds and turns out to be a quadrocopter, which just seems to fly autonomously into whatever scenery there is. I'm going to show that again. So this guy throws this package into the air, it unfolds, and voila, there is a quadrocopter, and off it goes. And I was thinking to myself, well, is this reality or is it just fiction? And by fiction, I mean waiting to become reality. And I did some research for a caged drone, a drone that would be unfolding, or anything similar, and I wasn't able to find anything. So it probably was fiction, and I decided I have to build it. I have at least to try if it is a concept that could be working. And since I'm a computer scientist, before I touch any hardware, I do simulations. And PX4, the ecosystem, comes with that wonderful environment or that wonderful tool, Gazebo, which I used. I put in that simulation framework, I put a quadrocopter on the ground, attached some force to it to throw it up into the air to simulate that rotating and translational movement into the air. And as it turned out, the software was fine with that. So I went ahead and did some hardware-in-the-loop simulation with an old PixHawk that I had lying in my drawers, something that I also mentioned in my application for that talk. And also the PixHawk was doing well with that setup. So throwing something up in the air with a PixHawk and PX4 installed in it, apparently was able or should be able to recover that rotational force and stabilize itself and do whatever you tell it afterwards. And then I went to my favorite 3D modeling software, which is SketchUp. I know some people would say or would argue that it's a modeling software, but for me it's perfectly fine because it has very simple functionality, and I still can do stuff that I can later put on my 3D printer and have put out into the real world and touch it and use it. And while this model was printing, I was doing some research for motors and propellers I wanted to use. It should be small motors, small propellers that would fit into that mechanism, and that would be as small as the one that we saw in the movie. Let me quickly check this one. Okay, seems to work. And then during that research, I was thinking, well, why would I buy 4 motors and then search for ESCs that would fit to the motors and then search for propellers that would fit to the motors? How about just buy a whole package that's already harmonized with each other and that someone else already chose to fit together? And I went to buy a cheap quadrocopter on one of the bigger platforms. And on that platform, I came across this. And I mean, how about that? The Sim2 Moment Hoshi 007 Pro Air Selfie Drone, which is a very long name for a very small drone, looked almost exactly like the drone we saw in the movie. Two things about that. First of all, I was surprised that I didn't find that drone during my first research. And second of all, I was surprised that this drone was very, very cheap. Not even 100 euros. And it even came with a set of 2 batteries. And so I couldn't resist, and I ordered that drone. Despite the comments I saw on that platform about the drone that warned not to buy it because the software would be so bad and the controls terrible and connection loss, and it wouldn't work as well as announced. But I wasn't buying it to control it on my cell phone. I was buying it to take it apart, right? So the idea was, instead of doing that whole mechanism myself, just to use that cage, which is pretty sturdy, has the motors installed, has propellers installed. They are also sturdy, of good quality, and the ESC was already fit inside. So all I had to do was to add some power and a pulse width modulated signal, and I would have been good to go. So I put it together with my 3D printed model and that old Pixar I had lying in my drawer, and did a first test with the ESC, which didn't go so well. The MOSFETs, they just blew up. I'm still not sure what exactly was the cause for it, but I think I might have chosen the wrong PWM phases. Long story short, I had a broken ESC, and now, since the warranty already was void, I had to find a solution or a replacement. And the easiest and cheapest way was to order a second drone. I mean, there's a lot of other parts that I could use, so why not order a second drone? And while that second drone was on its way, I was having a closer look at what was lying on my table now. So besides the cage and the propellers with the ESCs, I had the 2 batteries, very compact, a charger, the power supply, and then the more interesting parts, like flight management unit, the Autopilot. And attached to the Autopilot, there is a board that I would refer to as the power distribution board. And then there was a separate GPS module, a very nice one. Then there was this other board that to me looks like an optical flow sensor board, since it has a camera and a microchip on it. More on that later. Attached to that board was the ultrasound distance sensor. On the back of the flight management unit, on a small styrofoam, so somewhat stabilized, or not stabilized, but well, it was on a styrofoam. There was the IMU module, which is an extra module, so you can disconnect the cable and use it as an extra module. There's a small chip that turned out to be a baro sensor. On the first drone that I got, there was a magnetic compass module. On the second drone, it was missing. It also said that this one was the version 1.2. I guess they rationalized it away. There was a Wi-Fi module, so I could connect my cell phone to the drone. And since it's a selfie drone, it also has a camera, and attached to the camera is a small servo. It's a quite capable camera. I think it's a 4K camera, which has a very good quality. Then there was a huge transportation case, shock absorbing, so also very good quality compared to the price, fancy box. And the only thing that was rather useless to me was a power cord, because it has a UK plug. But the rest was a surprise to me for that price. And then I had a closer look. I know it's not a word, but I think it's just fitting. And while I was looking hard at that board, I found that 3 of those boards, they had like these 4-pin connectors. And then I had a closer look, and I found, well, it's an STM32F405. And I looked up in a data sheet, and the pins are connected to the serial wire debug port. So as a computer scientist, I of course had to attach my programmer to it, and I found that the microcontroller was protected, but only to level 1, which means You cannot read the firmware that's on it, but you still are able to write new firmware on it. So it would be totally erased, but then you're free to add any firmware that you liked. And I was like, wow, that's like an Arduino, like any experimentation board, isn't it? And I did a Bestandsaufnahme. It's a German word, which means that I took the inventory that is on the board. So I started poking with some needles all those ports. I took some pictures, put the board under a microscope, put those pictures back and front over each other, and started tracing or following the traces, some sketches, and I ended up with an Excel sheet that had the pinout of the whole chip. And also like all the interfaces, I was able to get the baud rate for the UART and everything. And well, with that information, I went to my favorite IDE, which is the Cube IDE, because you can very, very easily set up a very basic application with that. And I put all the information I had about the interfaces into that IDE, added like, I think it's like 8 lines of code, nothing more, nothing less. Again, poking some needles into the UART ports in this case, and attached, I'm not sure if you can see it, attached a logic analyzer, and I had communication via UART. It was working just as easy as that. And this was for me, well, an open door to try something else, to connect the dots, right? And by connecting the dots, I of course wanted to add Autopilot software to that drone, and which Autopilot software would be better suitable than PX4. And as the documentation suggests, I started first looking, because I didn't want to reinvent the wheel, I started looking at a similar hardware. And I found it in the BitCraze Crazyfly, which is based on the very same microcontroller. So all I had to do is take whatever configuration existed for the Crazyfly and individualize it. So I took the bootloader and added the characteristics of the board. I created some basic firmware, put the bootloader via the programming port onto the board, and after that I was able to flash my first basics firmware via Q ground control and the USB port. So no more programmer, but the very same workflow that you have with any drone that is running on PX4, which is a great thing for that consumer drone I have. And the rest was like customizing and contributing to the PX4 repository. So since the time is quite limited, I think I'm already over it. I added some stuff to the bootloader. The whole board is running on 24 megahertz. The datasheet of the MCU suggests that the maximum would be 8 megahertz, but it's working fairly well with 24 as well. The IMU and GPS were working out of the box. I didn't have to do anything. I did have to alter something about the communication link, because it uses 2 ports to communicate to and from the Autopilot via the Wi-Fi module. The baro sensor was a bit special, but I found some firmware for it and just added some SPI drivers to it. The smart battery does provide a lot of information, like the voltage, capacity, remaining capacity, temperature, and things like that. And then I put everything together, put it on the drone. Then I started the drone. I'm not sure if you can hear the sound and see the video. And yeah, I connected my PC via the Wi-Fi dongle to the drone. I had to wait for the connection to establish. So I got an IP address from the Wi-Fi access port. So long story, no, short story long. This whole combination of Wi-Fi access port and camera works like any action camera. So you attach your cell phone or whatever portable device to it. You can only attach one device at a time. And then you communicate with the camera via a picture transfer protocol. So the communication towards the camera is not relayed over the autopilot, but it's directly via the Wi-Fi port. Not sure. So I armed the drone, and then it started. And since it has cages around the propellers, I was confident to have it flying above my desk, which, as you can see, was working fairly well. I was able to control the drone back and forth. Right. All right, so the things that are still open in that project, because it's still not finished yet, is to make sense of the optical flow sensor board. There's an IC on it, which I couldn't find on the internet. There's no documentation whatsoever of it. I think it might be some FPGA or some dedicated chip to process the image data and then give some, well, flow sensor information. The distance sensor board is also very easy, but still work in progress. The picture transfer protocol that I mentioned needs to be put into Q ground control, would be a nice thing. And also the control of the servo. And of course, much more flying that needs to be done. Bottom line is hardware is hard, definitely, but without the software that brings it to life, even hardware is just brick. And the second thing that I learned during my project is that the PX4 community is awesome. You can put out questions and they will be answered. The whole open source software, the open standards, everything is so easy to use that even I was able to get this drone to fly. I think I already am way over my time. So if you want to learn more about that project, feel free to have a look at my blog or just send me an email, have a look at my LinkedIn profile. Would be nice to get in touch. And yeah, thank you for being here and for attending this presentation. All right, so there's even some questions. Did you test throwing it into the air, Julian? To be honest, I haven't. But that's definitely on my list. And to make it more real, I'm also thinking of putting some rubber band around it and some kind of mechanism so that it would unfold. As soon as I do that, I will post the results on my blog. The drone is very cheap. The last time I looked at it, not sure if I'm allowed to say it here. I'm doing it anyways. It was on Banggood, and it was like 50 or 60 euros. So, I mean, that kind of hardware, this whole pile of parts that you can use with any drone, because it's like the GPS is a UART GPS. You can use it for other projects. It's very, very cheap. The flow board is sending out serial data, yes, and I think if you put some more time into it, you don't even have to flash some new firmware on the well, it's a clone of the STM32, which is called the F103, and I think there might even be some drivers out there because I can imagine that they didn't reinvent the wheel themselves. How did you find out which components? Well, I have to admit that I'm not a foreigner to the drone industry. I was working as a lead developer for a big drone company, which is where I learned a lot about the special things or the specific things about drones, but I was always in aviation and I'm a computer scientist, so I was always interested in connecting these two and which better way is there than working in the drone environment, right? The work is already on GitHub, so if you have a look at my blog, all the steps are explained. It's like a 10 part project. And I tried my very best to explain all the things that I experienced. And also the software, everything I did is out on the GitHub. I'm very happy to share it because I have learned very much of the open source and of that community, so I'm very happy to give that back. EKF2, yes. Thing is, during that project, there was a major update of the PX4, and I rebased my project on that. And unfortunately, well, the space, the memory on the F405 is very, very limited. And with the new update on PX4, the binary was a little bit too big, so it didn't fit on it. And I think I had to remove the EKF2, but I'm not that sure anymore. So best thing, Gonzalo, would be to have a look at the blog and at the GitHub repository. All right, I think there's already another session going on. I'm sorry that I have been stealing some time. Thank you guys for being here. Hope to hear from you soon and to stay connected.